Let's look at our next problem statement. Write a program to check whether a number is a prime number or not. Prime numbers are divisible by only two numbers, 1 and the number itself. Okay, so let's write a function for that. Is prime, and it will accept a number. So let's begin by saying yes, that is a prime number. So prime equal to true. Try till is equal to int number by 2. From the previous program, you must be clear why I am doing this. Try till equal to int number by 2. Okay, for I in range, since it is divisible by 1 in any case, so let's say from 2 onwards, try till. And since the number itself is divisible by itself, we don't even have to say plus 1, right? So now we can proceed. If number mod I is equal to 0, that means it is divisible by I. If the number is divisible by I, that means we have found a number which divides this number. So that means prime is equal to false. That means it is not a prime number. Okay, and we can just say return prime. Now, important thing here is that if we are talking of a number like say 101, right? So what will happen is, the moment it goes into this loop, there is no point in going forward, isn't it? Because if it is divisible by any other number, then it is not a prime number. So there is no point in dividing by any other numbers further on. So we have to come out of this loop, for loop. So we say break. When we say break, it will not repeat anymore. It will come to return. Okay. Now let's define our main function. N is equal to int input, enter a number, and print formatted output within quotes. I want to print a text within quotes, so that is why one extra single quote I am putting. N is a prime number. But if I do that, okay, I'm putting it in a string. Is, that means that statement is prime n. Now let's call the function main, and we will see what the output would be. Now let's close off this. Let's edit the configuration, change this to prime number. Okay, run prime number. Now let us say 9. 9 is a prime number is false. 2 is a prime number is true. Let's say 3 true. 5 true. 7 true. Let's say 91, it is false. So can you think of a number which will divide 91? If you can't think, you go to the other program, factors of, and you provide 91 as the input. It will tell you 7 is a factor. So 717, 2 remainder, 273 is 21. So 91 is not a prime number. Okay, let's say 153 is false. Again, this 3 is a factor of. So it tried to divide it by 2, then try to divide it by 3. The moment it divided by 3, it found that it is equal to 0. The remainder is equal to 0. So prime became false and it came out. Just by 2 repetitions, it knew that it is not a prime number. Let's try something tricky. Is 1 a prime number? Here it says true, but it is not. 1 is not a prime number, because a prime numbers are divisible by only two numbers, 1 and the number itself. Here it is divisible by itself. So it is divisible by only one number. So how do we take care of this? So what we'll do is, if number equal to 1, we will directly say return false, and this whole thing will go into else. Now let's try this. 1 is false. Let's just try some other number. 9 is false. Let's try one more. Let's say 53 is true. So you need to be very careful of the logic behind a particular problem statement. That's it. Bye.